as was introduced, my topic is going to be around the Open Standards APIs for SDN. Now, let me actually start by asking you guys a question that how many of you know what SDN is? Everybody knows. Fine. So give me an answer. What is SDN?
1 second, wait for the microphone.
I can quote one of the inventors of the OpenFlow who said that he doesn't know what SDN means anymore.
That's a good answer. Do not know. I agree on that one. See, the fact is that, I mean, if I ask the question in the audience as I did now, my guess is I get like 15 different answers, right? Because I don't think anybody can say what is SDN. It might be, in somebody's opinion, a blueprint. It might be, as you said, a protocol, OpenFlow, right? It might be so many different things. So on a high level, you know, what I'm going to talk about is pretty abstract. So having said that, keep in mind, I have 25 minutes to actually cover kind of a pretty abstract topic being the APIs for SDN. How many of you guys know OpenDaylight? One. How many of you know OpenStack? A couple of ones. Okay. So this is not getting easy for me then. So let me start by this one. This is like I'm supposed to give a technical presentation. I'm starting with some marketing slides. So, you know, this is the high level. I'm just trying to build a picture for you guys. So if you're familiar with the IFTT, which is basically it's a web application that's kind of, you know, doing simple commands and chain of simple commands to achieve something. So for instance, you know, assume you get an email with a PowerPoint attachment. You want to, you know, save it to a Google Drive. Assume, you know, assume that you have a stock portfolio, stock goes up, so what do you want to do? You want to sell it, so on and so forth. So this just goes through a scenario of multiple applications. I'm not going to walk you through each of these. The key why I'm showing you this is basically that it's all about applications, right? It's all about some kind of APIs. So what you have is some kind of a consumer and a provider, right? It's applications and, you know, things around that one. So moving to the next slide, basically. So looking at SDN. Now, as I said, that was like just, you know, some basic stuff for applications, what can be done. It's basically, you know, service chaining, or you could do multiple things in a row of you know, things happening. So looking at the same example now, let's get the build up here. So from an SDN point of view, what have you? Basically, you have the same thing here out now, right? It's a matter of applications. You have multiple applications. It might be, you know, a consumer of an application or a provider of an application. So this might translate into an application as such, doing something, or a consumer being a plugin, actually doing some kind of an action. So, kind of giving the same example. Assume you have a medical device connected to your network. It's going to be going through the firewall because of certain criteria. Assume you have a link video call. That given call is going to need some QoS stuff. It's going to need some bandwidth parameters, so on and so forth. Assume you have a device that's found to have some vulnerabilities. It's going to go to remediation server, so on and so forth. So as we go, you know, further and further, you see more and more basically applications with certain criteria. Now, as we see here, this is like you know, a simple or a single application demanding something. Having said that, obviously you could have a chain of commands. You could have, service chaining, if you have heard of that one. Multiple things happening, in some kind of a chain of actions. Okay, so that was like the base for what I'm going to talk about. Now I'm actually getting into the real stuff I want to talk about. So as I asked you guys about OpenDaylight, how many of you heard about OpenDaylight? And basically not that many have heard of it. So OpenDaylight is really, about a controller platform, an architecture, where you would then basically, have some kind of abstraction layers and APIs. So I'm not going to read through this slide, but it's, the OpenDaylight is based on the open source project under the Linux Foundation. It's all about basically being able to provide services to users in a network. So looking at the architecture for this one, sorry for the picture, it's pretty bad, but what the picture shows you is northbound. You have some kind of an API. It's a REST-based API which allows application to talk down to the controller. So this is, might be a web application talking down via a well-defined API to actually provide a service. Then southbound, you have some kind of a service abstraction layer. So here you then basically see a variation of plugins. As you can see, you have an OpenFlow plugin, which obviously talks to OpenFlow-enabled devices. You have an OVSDB plugin talking to Open vSwitches, so on and so forth. So at the end of the day, what I'm trying to tell you guys is that you have an application that's actually doing something, going through a controller platform that's going to have some kind of plugins that would eventually create whatever the application is asking for. Now, if you guys remember the like OpenFlow 1.0, where you had an OpenFlow controller and you created a flow and everything was OpenFlow, it was more or less, connecting APIs together, right? So the key with this one is really the fact that you have a service abstraction layer, which means that, this is the layer you're actually going to write against to actually have some kind of modeling happening for a given thing to be more or less created in the network as a consumer. So the basic for this, keep in mind again, I'm going to have like 20 minutes to talk about all the in-depth of OpenDaylight, all the APIs, everything like that. So keep in mind what I'm talking about is pretty much high level. For you to understand actually, what I'm talking about, the APIs and really about the service abstraction layer, is the fact that what you see is the blueprint of the high-level architecture, basically. What you have is the OSGI framework, which is basically the place where you load your bundles and your plugins. You have, this is the place where you register the dependencies and so on and so forth. And then on top of that one, you have Karaf, which is like a lightweight runtime for the ODL itself running in a container. And then on top of that one, you can see the features, which is basically the bundles and the modules, as kind of the name of the topic here. So in a high level, it's all about different modules and bundles. Now, why am I actually talking about this? It's due to the fact that me as a designer or a developer, I'm actually going to develop against this. There are certain tool sets that I'm going to use within the ODL, OpenDaylight architecture, that actually is utilizing these. So if you're kind of lost on this stage, ignore it, because this is just giving you a high-level view of what I'm talking on as the next topic here. So I'm breaking this now into, if you recall the previous picture with the OpenDaylight architecture. Now on the left-hand side, you have the northbound, which is pretty straightforward in the sense of it's based on a REST API, right? So it's a web-based application. You have a certain amount of constraints, 6 of those, that the API must follow to basically, do things. And then you basically have, on the right-hand side, you have the southbound service abstraction layer. Where, as mentioned, you see, it's more about plugins talking to various hardware pieces and bits, as we see OpenFlow talking to OpenFlow-enabled devices, or VSDB talking to Open vSwitches, so on and so forth. And then you have basically 2 different service abstraction layers. You have the MDSAL, which is really the model-driven, and then you have the ADSL, which is the API-driven. There is quite a big difference in both of these. So I'm actually going to ignore the northbound side because I think it's pretty straightforward. This slide basically just covers, what's happening on the northbound side. I think key thing being is that this is a REST API that you basically write your application against. That would then orchestrate something, provision something, do something for you from an application point of view. So let's skip this one. Let's go to the next one, which is really, as I said, the southbound service abstraction layer. And this is really the key philosophy behind OpenDaylight, that the model has been really written around this, this architecture. So, as said, you have the service providers or producers, which is a protocol plugin. It do talk some protocol, like VSDB, like OpenFlow. And then you have the consumer, which is an application. And then at the end of the day, what it's all about is to kind of get these connecting together in some way. Now, as you can see, the last line basically says that the idea of abstracting this is for the developers to actually more work in a silo, working on their given application or their given, business problem they want to solve with a plugin, with an application that's going to be pushed out into your infrastructure in some way. So this shows you on a high level the ADSL. As you can see here, it's basically all about a API-driven service abstraction layer. What you'll have is a southbound plugin and a northbound plugin. And then you have something called the request routing, which basically means that you are going to provide connectivity between these APIs. So really the northbound, southbound doesn't matter, because at the end of the day, it's a matter of request routing between these different elements. It's connectivity between these elements. It's like plumbing between these ones, right? You do have some kind of abstraction happening here as well. So as you can see, you might have a plugin connecting in here to an adaptation layer, and that's going to translate it once again into request routing, basically providing the connectivity, right? Now, if we compare that one to the MDSAL, as you can see, this is getting a bit more complicated now. So you have the same thing, you have a southbound plugin and a northbound plugin. But as you can see, you don't really have any request routing here. You do have some kind of an API, southbound, northbound, then you have a data store. And then you do have your request routing, and you have an adaptation layer here, a plugin. So anything from a northbound to a southbound would actually go through a data store. That would then, with RPC calls, request routing to actually connect these ones together. And then you have some other components included in this picture as well. So as you can see on a high level, if you compare this one, you have the request routing on the ADSL. On the MDSL, you have the request of routing where RPC calls and notification of routing. So anything happening here will also be notifying what's going on here, compared to on the ADSL. You have service adaptation here. You don't really have service adaptation as such on this one. You have a data store. So you always work against the data store or data tree. That's where everything is happening, glued together, so to speak. This is giving you an high-level example of OpenFlow together with the ADSL. It's pretty straightforward. So you have a packet coming in here. You talk to your OpenFlow protocol plugin here. And that would then initiate the call up to your service abstraction layer, which would then basically talk to any of the modules handling that one. And then you would go down through the service abstraction layer and push out basically your flow through your OpenFlow protocol plugin here. It's no rocket science, it's pretty straightforward. Now, kind of looking at the MDSAL, so that was the ADSL from an OpenFlow perspective. From the MDSAL, it's completely different because as the name actually says, it's a model-driven, which means that you as a designer, a developer, actually create models that you would work against that would create a given plugin for a given function. So, sorry guys, this is pretty abstract, but I'm trying to walk you through this. So, what happens is that basically, you can see first of all the key differences between ADSL and MDSL. Provider creates model of data and service they expose. Models are in the form of Yang definitions. Yang compiler is used to create uniform APIs. And these API do generate high-level uniformity between each terms of usage and definition. So basically, to give you an example, walk you through this picture. So what happens is, here you basically have a designer creating some kind of a model for a data tree. So assume that you want to create a plugin for a given function. That plugin is actually written in Yang, or is actually exposed to Yang. That's run through the Yang tools, and you then get some kind of a definition of that one. That definition would then be sent to some other management, some other building tools, and you would create some kind of an API bundle. That bundle would then be loaded to controller. And once again, keep in mind that you work against some kind of a data store, a data tree. So on a high level, this, how you, with a given set of tools within your OpenDaylight controller, actually create these bundles that you would then load into your controller. That would eventually be the plugin doing a given function for you on the southbound API, being a model-driven service abstraction layer. You basically have the same example here now that goes through how the same thing happens with MDSAL compared to the ADSL for OpenFlow. I'm not going to walk you through this. This is actually an in-depth walkthrough of what's happening. So you can read this on your leisure. It's, this one I want to basically touch a little bit more on due to the fact that what I talked about, as said, is pretty abstract, right? Now, how would you deploy or apply something like this to a real-world scenario? Well, to give you an idea of a demo that I did at the EuroIX forum meeting, I'm going to walk you through the demo and kind of for you to understand why SDN is pretty interesting in many aspects. So what this basically shows you is you have some kind of an exchange, which is more or less a cross-connect. Many times it's built based on MPLS, right? VPLS, which means that you have a full mesh of connectivity. Now, what you'll have is, in this picture, basically four PE boxes and one P box, one LSR and 4 LERs. At the end of the day, what's happening is, from an MPLS point of view, you are going to create your LSPs, your pseudo wires, having all your signaling going on, all that stuff, to eventually create a full mesh or a fabric, right? So this is just a short kind of walkthrough of the demo itself. Obviously, the first thing is that you would have a OpenDaylight controller, an OpenFlow controller, basically, because at the end, we are actually using OpenFlow 1.3 to create the MPLS-like pseudo-wire connectivity. So first thing is to connect the controller. And as you can see, you basically have some kind of topology map here showing your 1 LSR and your 4 LERs. Then you would have some kind of an application that would create your flows. Because at the end of the day, it's a matter of creating a flow, right? And at the same time, you would have traffic TX, so sending, you would have actually traffic generators on each and every PE. You send traffic into the fabric. You do not receive anything yet. Because keep in mind, by default, what you have configured is nothing from a flow perspective. From a flow perspective, this is what you need to actually be able to create the flow, right? So the next thing is actually to go to the switches and look at the open flow of the groups for open flow. There are none. The next thing is look at the OpenDaylight and see that your devices have been discovered. As we can see, you basically have a map of your devices. The next thing is that you would run your given application here that would eventually create the flows. So an application talking via the REST API down to the OpenDaylight controller that's actually then talking open flow down to each and every switch. Now, you are looking at the Ixia or the traffic generator, and now you actually start to see traffic floating bidirectionally, which means that a flow has been created from this given application for this MPLS fabric with a full mesh of connectivity. Well, this as such is not that unique. So if you go and look at the OpenFlow stuff, you would see your flows, your groups, so on and so forth. You would see your switch names appear, so on and so forth. I'm going to skip through this, but this is for you guys to get an idea of why this kind of makes sense. What I'm showing you now is from an extreme switch, actually, the configuration. This configuration is without SDN enabled as such, without any open flow. So what you'll have is your basic MPLS config. Then you have your RSVP config, right? Your LSPs, your primary, secondary path, so on and so forth. Your peers, your EROs, many variables. Then on top of that one, you need to actually have some kind of pseudo-wire connectivity based on VPLS. That's where you create your VPLS, you add your peers, you create a full mesh of pseudo-wires. Okay, so this is without the SDN. Now, if you look at the same config, with the SDN flows created, the only thing you have is basically a couple of lines configured for MPLS as such for the connectivity from the LER to the LSR. But for the RSVP part, you don't have anything due to the fact that you do not have any signaling happening for the LSPs. For the VPLS part, the same thing. You do not have any pseudo-wires created as such based on LDP or any other signaling. So all of this is actually happening back-end from the controller, from the SDN application creating the flows. So as such, from a use case, this is pretty interesting because you do get rid of all of the complex MPLS stuff, right? But still you have a full mesh of pseudo-wire-like connectivity for this. So this is one example. This is actually another example where you could use SDN approach, where you would have then your Skype for Business or link calls going on. In a nutshell, what's happening here is that you have your end users being either wired or wireless. You would then have your link front-end server, and then you would have your kind of common server for that one. You would have a call initiate into the front-end server, and then connecting into the central server. And the central server is running some kind of an SDN API towards your net sites running the one controller API, SDN API. That would then basically talk to a NAC appliance here, and you have one controller, SDN controller here as well. And at the end of the day, actually using my NAC over here, I would know my end users, and I would be able to identify a given link call going on. And for that given link call, I would actually push out QoS profiles, I would define DSCP code points, so on and so forth, to guarantee quality for given calls. So this is another use case for how you could actually use that one. This is some key points, so I'm not going to talk through those ones, but this basically shows you another way of an SDN-based application, you know, from this point of view. So I guess I'm running out of time, so I would conclude my presentation on this one. Do you have any questions? Did you understand what I was talking about? Probably no, because it was pretty abstract, high-flying. As said, you know, my key message is for you guys to understand that, you know, from an SDN point of view, there are many interesting use cases where you could apply that one. Why did I talk about all the MDSL, ADSL stuff? Is for you to realize, understand that, you know, it's all about providing the connectivity from an application point of view to a plugin and doing the plumbing between those. So yeah, any questions? Okay, thank you.
Thank you very much.